don't watch it tonight. Or they would have behaved better the first time around. That's why I set up Edmodo.
What percentage is it called rated by final test?
It's 15 or 20%. All right. Shh. Right this minute. Shh. Number 15. Put your hand down. I do too. Can you not? Shh. Hush. Shh. Let's finish number 14. Now, what are the diatomic elements? These are the diatomic elements, okay? All right, now, which is the correct formula? Will. Which formulas A, B, or C, which equations A, B, or C are incorrect on number 14? 14, we already eliminated D. What else looks incorrect?
A and B look pretty incorrect.
Shh, I'm asking Will. B. Look at that. Right there. Wrong. Okay, good. Will, what else is wrong? Nope. See, look at this. See that? Oxygen, what's wrong with the oxygen?
How did you put a 2 on the oxygen? H2O, that's water, so how is it like?
What's wrong with it? It's not
So
diatomic.
H2O is supposed to
Kendall, can you hand me that coffee cup over there, please?
It doesn't necessarily need it, but as the diatomic or whatever, the seven of them always have a 2.
Thank you.
It doesn't make any sense. H2O is not supposed to be 2H.
Shh. Yeah, all right. Listen. Shh. These elements are diatomic when they are elements. Does that make sense? As elements? Right here, is water an element or a compound? Compound. This is a compound, so it doesn't have to be diatomic anymore. Is that what you need? What you need? Oh, it's gone. All right. So, number 15. Which type of strong intermolecular force is pictured in the figure of the solid water molecule? Now, let me show you something about the solid water molecule, guys. Solid water molecule is actually less dense than water. Did y'all know that? Ice is less dense than water. What's a very visible indication of the fact that ice is less than water? Yeah, you don't have to go to the Arctic Ocean to figure that out. Where do you figure that out every day? Maybe at lunchtime. Where? What happens to the ice in your drink? It floats. If it melts, then it's not there, is it? Okay. Shh. The ice floats. Be quiet. The ice floats, and that's because it is less dense. If you're going to talk, go to the back of the room again. Less dense than what? You can't just say it's less dense than something. Water, very good. All right. All right, and this is solid and this is liquid. We're going to come back to that soon. Okay, Brian? Yes, so now, 15. Intermolecular force. The reason it's a hydrogen bond, good, Brian, is because it's hydrogen plus either nitrogen, oxygen, or fluorine, and we have that situation, okay? Next, 16. Now, what are the intermolecular forces? You know what? Let me tell you a practice thing. Chris, make sure you're listening to this. When you see a question like this, do you know what that means you need to know for the test? You don't just need to know what hydrogen bonds are. You need to know what dipole-dipole dispersion, and very good, Brian, you need to know what all intermolecular forces are. Okay? So the intermolecular forces that we're studying here, or that we studied this chemistry season, were these three: hydrogen bonding, dispersion forces, and those happen within non-polar molecules like chlorine, for example. Dipole-dipole, they happen with polar molecules but they're polar molecules that don't have nitrogen, oxygen, fluorine. For example, CH3Cl is a polar molecule if you draw it out. Looks like this. But do you have hydrogen bonded to N, O, or F?
No.
No. So this would have dipole-dipole forces. All right. So chlorine is nonpolar. It would have dispersion forces. All right. Next. 16. 16. You have a volume. You have a temperature. You have a pressure. Again, another pressure. Another temperature. Okay? Now, what equation, kids, do we need? Beautiful. Combined gas law. Good. All right. If you know some of these things, please be proud of yourself because you're one step ahead of the game. If you can look at this and not be overwhelmed and say, "Oh, I don't know any of this stuff," okay? Or if you're sleeping through it because you just give up, all right? Then that's just too bad. But those of you who are with me, Dwayne, focus. Then we're good.
I'm trying, Mom.
All right, very good, very good. All right, now, I want to know what volume we will have at a new pressure and a new temperature. All right, here we go. I'm solving for V2, so I'm going to rearrange the equation. What do I divide both sides of the equation by? P2, T1. Let's just rearrange it like this, and then it's a little bit easier when we go to plug things in if we're just dealing with the variables. All right? Oh, it sure is. All right, thank you. Let's see. All right. Now, what do we always do with the temperature? Chris Albert?
Convert.
Student of the week. What do we always do with temperature when we're plugging into one of these gas law equations? We can't leave it in Celsius, so what do we do?
At 273.
Kelvin, right on. Yeah, Sam, Chris. Good. Try to be more like Chris. Do you see what Chris is doing? He's writing on paper.
Were you student?
And even better, I don't even know if Chris Albert has a cell phone. He keeps that confidential. Oh, I forgot you weren't using it, right? Yeah. All right. Shh. V2. Now, Garth, where's my P1? What's P1, kiddo? Original pressure. Is it 1.08 atmospheres?
Yes.
All right, I'm going to put my initial pressure right here. Sit down. What's my initial volume? Is it 50 liters? Say yes. Ooh, what's the new temp? 273 plus 10, right?
What was 25?
Hold on, let's keep going. Where? Yeah. Now, what is P2? What's my new pressure?
8.885.
Yep, 0.855. And T1 is this. So that's what Hunter was asking about, where that 25 belongs, and that's where it goes. 25 plus 273 equals 298. Now, units cancel. Kelvin, atmosphere. We're left with liters, which is lucky because volume, Jess, likes to be in what unit? What unit do we like volume to be in? Liters, all right? So, what do I do, Miss Casey, with these three numbers with my fancy calculator? What operation, mathematical operation, do I do?
No.
We multiply across the top, 1.08 times 50 times 283. Now, divide by. Don't you think if they're both in the denominator, we have to do the same thing to both in the calculator. So hit divide by, hit divide by. All right, and we're going to get an answer. And what is the answer? I don't know it, but you can use your little answer sheet to figure that out. Is it Mr. 60? 60. Got it.
Actually, they looked that up.
What's going on?
He said, this is how we do it. This is the first thing you want to do this.
Okay, number 17. Oh, Sam, what are we going to do here? We have a pressure. We have a temperature. We have a volume. We need moles. What is the equation? Did you know that you don't have to put this equation on your note card because it's on there? What is the name of this equation? What? Oh, good, Chris. It's the ideal gas law. Okay. Now, how do I rearrange that to solve for n? Say, let's divide everything by RT, Miss Milam. Very good. Good. All right. Did my student of the week repeat after me and say?
No. It's not, you didn't hear my name up there? I asked you.
When?
Miss Palmer.
Miss Palmer? For what?
Physical
What?
Science.
You're not taking physical science last semester?
Not anymore.
When did you take physical
Last
science?
semester. It's kind of hard to believe, I know.
Dwayne, there are a lot of good things that I like about you, and I want you to be my student of the week. That's why I keep heckling you, because I want, I'll tell you later.
What, are you going to let Jay come back himself?
He can watch this on Edmodo if he wants to watch this.
He wants to come back himself. Let's go get him. Jay, you can come back in.
All right, what are we going to do with 31.8 and 273, kids? Edwin, are we going to add these together?
What are we doing exactly?
Converting from Celsius to Kelvin.
Oh yeah, we're gonna add those together.
That's kind of a fun. You just get to add something to convert. You'd never think that's the way it is.
Reese's Hopes.
Did y'all know that Edwin is a chemistry star?
Chemistry wizard.
Yeah, mostly because he had such a wonderful physical science background that got him going.
Thanks to Ms. Milam.
Yeah.
PVNRT.
Yes.
Are you guys doing gas laws?
We're reviewing everything, so yes, this is a review of the gas laws.
Miss Collinsworth Bowling.
Yeah, isn't that funny? All right. So, Edwin, what do I do with the two numbers in the numerator?
What are you trying to get?
We're trying to solve for n. PV divided by
Just
RT.
multiply those together.
Yeah, multiply these together. All right. Katie, you ready? He's going to tell us what to do next. And then what do I do in my calculator right here?
You can multiply those together too, because they're gonna end up canceling out.
Well, yeah, but you know what I teach them? That they have to divide by, divide by. Well, that you can put these in parentheses and multiply them together, but I want them to do this. Then there's less buttons to push. They don't have to hit the parentheses. There's less room for error if you have less buttons to push. Yeah, you know. What class are you in now?
Literature,
Oh, yeah.
the same class I'm always in. That I'm never actually in.
Right. And we're on tape
I have like
right now.
95 in there.
But you never in the class.
I know.
That's the kind of student Edwin
I can't
is.
tell you.
Because he pays
trust anybody.
attention when the teacher
And he gets
is
the teacher's
talking.
notes.
I'm not gonna snitch on myself. What if you happen to walk by and be like, "Oh yeah, I saw Edwin in Ms. Milam's class," and she's like, "Whoa, yeah, he wasn't supposed to."